Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at switch hardware. We'll be discussing switch platforms, switch form factors, port density, forwarding rates, power over Ethernet, multi-layer switching, business considerations for switch selection. In this episode is part of my series on enterprise networking, security, and automation for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. When we start talking about switches, there's a variety of switch platforms, form factors, other features that you got to think about before choosing the switch. When designing a network, it's important to select the proper hardware to meet your current requirements, but you also have to allow for that network to grow. Within an enterprise network, both switches and router play critical roles in your network communications. Here we have campus LAN switches. These are your access layer switches. Typically, these are only layer 2, and they support high concentrations of users with these connections. You can see on this switch right here, this top switch, there are 48 ports here. There are 48 devices that can connect in here. So this would be good for like a room or a floor of computers. You can't necessarily say 48 computers because you may have 36 computers, but then you have to connect in a printer, maybe a second printer and a scanner, some IP phones. And before you know it, you have more other devices than computers actually connected into your campus LAN switches. This is the Nexus platform of switches. This promotes infrastructure scalability. And what happens here is you can build these and kind of put the devices, the slots in here that you need to make it for your company. We have operational continuity and transport flexibility. A lot of times you see all of this in your data center. Down here, this is Meraki. What Meraki is a cloud-based managed access switch enabled virtual stacking of switches. Meraki is for that company that doesn't want or can't afford a full-time IT staff. What you do is you contact Meraki and tell them what you need. I want to provide wireless access. I have 16 devices in my network. They'll work with you. They'll engineer a solution and they will configure it and manage it. All you have to do, they'll mail it out to you. You have to plug it in, plug your devices in, and that's about it. Meraki takes care of all of that for you. As you're traveling around, when you connect into all these guest Wi-Fi networks, wherever you're at a restaurant or a hospital or a store, you connect into it. There's a good chance you're going to connect into Meraki. Scroll all the way down to that acceptance screen, and a lot of times you'll see powered by Meraki. That's because they don't want to have a IT support staff. They don't want to pay somebody. They just want somebody else to set it up, configure it. All they have to do is plug it in. Now, they might have to hire somebody to come in and install that access point in the ceiling and run a wire over, but you can easily contract that out. And you don't have to worry about managing it. If you want to make a change to it, you can do it yourself if you want to, or you can call up Meraki and say, hey, I need to add in 40 more ports. I have to expand, and so they'll send you out another switch. I need to add in, I need to change the SSID or the password on my Wi-Fi. They will do that all for you. It's a managed solution. Meraki manages those Cisco products for you. We have the service provider Ethernet. These are the big boys of switches. These are at your service providers, your internet service provider, your connection service provider, VPN service provider. These are these big switches. Now, they provide application intelligence, unified service, virtualizations, integrated security, simplified management. These devices, you're talking mini fridges, or this one is almost as big as a fridge here. These are big devices. They do a lot. But your service provider is in the business of doing network services to provide out. They need equipment like that. This equipment is there. We also have the Nexus Virtual Networking. Now, this is a switch platform. It provides a secure multi-tenant services by adding some virtualization intelligence technology into your data center. It helps you manage, helps you in your data center. When you look at buying your switches, you need to consider what the form factors are. We have a fixed configuration, we have a modular configuration. Here in our fixed configuration, you will buy a switch. It'll be configured with a certain number, a certain type of ports. Here there's 48 ports here. In the main area of the switch, looks like there's 8 SFP switch or ports over here. That's what you get. That's what that switch will always have in the future. You cannot change that. It is fixed. Then we have our modular networks. And what these are, we see that we have kind of a mini fridge here. And when you buy this mini fridge, when it comes from Cisco, what happens is all of these connections, and these here look like these will take network cables into it, your unshielded twisted pair RJ45s. These are all blank. These are empty shelves in here. And you have to purchase each one of these cards, these slots, you have to fill them up individually. And so there'll be an added cost for that. So you buy the outside container, then you buy the cards and the slots in there. There's a control module, there's power supplies in there. And as time goes on and time changes, you want to add in some more ports. You need to upgrade from fast Ethernet to gig, from gig to 10 gig. What you can do instead of replacing this whole switch is you can pull out one of these slots and put in your new card in there, and you have upgraded that. Where with the fixed configuration, if you want to go here from fast Ethernet to gig, what you have to do is buy a whole new switch, take this one, get rid of it, and then install the new one. You have to completely replace it. So fixed and modular form factors. And one of the biggest changes in the last couple of years is stackable switches. What this is you buy a fixed form factor switch, and then you can stack them on each other, and with cables in the back you can connect them up. And you can see that there's cables connecting. We have some cables running here between these switches, then the top one is connected down to the bottom, and so these are all connected in a modular way here. That it provides redundancy, so if one of these goes down, there'll still be a loop here, but you can add in. If these 1, 2, 3, 4, 5, 6, 7, 8 U's of switches isn't enough, you could buy another one and stack it right up on top. And then you could wire that in, make it work. Now, I did mention a term here, a U of space. What a U is it's one rack unit. This is one rack unit. The device or the space that'll allow one of these to go in here. This is 1.75 inches. This is 1U. So these switches are all 1U. There are switches that are 2U. That'd be 2U. That would be, I don't know, 3.5 inches big. If this was all connected. Servers come in the same thickness. You can have a 1U server, you can have a 2U, you can have 4U servers. A U is a rack unit. Each one of those units is 1.75 inches big. Another thing to consider when you're ordering your switches is the port density. The number of ports on that switch. For your fixed ports, or your fixed form factors, for 1U switches, they typically come in, this is 48 ports, and we only usually count the ports that are over here in the main area and not necessarily the expansion or the uplink layer. We typically do not count those. We only count the ports in the main area. Counting all these up, it comes in 48 ports, 24 ports. This would be 12 ports. These are all SFP ports, and those are 12 ports there. Now, on our modular switches, so this is a modular switch over here, And each one of these slots you can replace here. Some of these modular switches, they can have up to 384 ports in them. They can have a lot of these cards. Each one of these cards has 48 ports. 48 ports times, I believe, 8 gives you 384 ports. So you can have 384 end devices in there. You could have, what is that, 150 users with PCs, voice over IP phones, and then connect in all of your printers and cameras and whatever devices on your network. You could support a decent sized office with this. I hope you're liking this episode on switch hardware. If you have the time, please leave a comment and let me know what you think about switch hardware. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Another thing to consider when you're buying switches is the forwarding rate. What the forwarding rate is the processing capability of your switch, and we rate it by how much data we can have that switch process per second. Now, different switch product lines are classified by their forwarding rates. Entry-level switches have a lower forwarding rate than enterprise-level switches. Now, if the forwarding rate is too low, so that forwarding rate is a low number, it cannot accommodate full wire speeds across all of the ports. It can't handle it. If everybody on each one of those ports decided to send a full load of information at the same time, what would happen is that switch, if it had a low forwarding rate, would get overwhelmed. And all of a sudden you'd start losing packets, dropping packets, because the queues got full. Once the queues are full, data gets dropped when those queues are full. And so this wire speed is the data rate of each port. Data rates can be 100 megs, gig, 10 gigs, or even 100 gigs nowadays. And these access layer switches typically do not need to operate a full wire speed because they are physically limited by their uplink ports. A lot of times you'll have your 48 ports in your main area, and then you'll have some uplink ports. Those 48 ports here will be a gig each. So you got 48 ports trying to do a gig each, but your uplink ports are only 10 gigs. And even if you ether channel those 10 gigs together, you're going to have 40 gig upload, but you're going to have 48 gigs worth of information coming in on each one of those ports. And so you're going to be limited by your uplink ports. So you always need to pay attention to your uplink ports while you're looking at your forwarding rates. As we look at the devices on today's networks, we have other devices besides those normal PCs. We have IP phones, we have access points, we have cameras. Now, to run those all need power. To get power to them, you have two choices. You can run power up to them. That takes an electrician to run wire up there to install the socket while following all the electrical codes. That is pretty costly, pretty quick. Each outlet you're going to install runs anywhere from $200 to $500 right away to get that power outlet out there, or power outlet up there. Then once it's up there, you have to go plug an adapter into it, plug the other end of that into the device you're doing. So like on an access point or a camera, it's going to cost you a couple $100 just to mount it up there. The other way to get power to those devices is to use power over Ethernet. We can get the switch to inject power on those normal Ethernet lines that will power your devices. The power needed here is typically between 44 volts and 57 volts. In most areas, that's considered low voltage. When it's considered low voltage, you don't have to be an electrician to install it. You don't have to hire an electrician to install that wire up there. You can get on a ladder, you can run that wire up there. As long as you follow the codes, you're good to go. You can use power over Ethernet. You don't have to have special adapters. You don't have to plug something into the power outlet on the wall. What it takes is you have to have a special switch. Now, this power over Ethernet switch, usually fairly expensive, But when you start factoring in the cost of getting an electrician and running wires up there, you can fairly easily make the power over Ethernet switch very attractable. What happens here is we have our data lines. Data is sent over our Ethernet cables. If we look here, yes, this is Cat5e, but Cat5e uses 2 pairs of wires. And on those 2 pairs of wires for a PoE, what we can do is we can inject power on that. 1 pair gets positive power, 1 pair gets negative power. We can send that. We can run this across, up the wall, across the ceiling, down the wall, through the wall, onto the desk, and connect it into the phone. And that phone will boot up by the power in that phone. What happens here is we put a transformer here, and it pulls the power out, or injects it back in case of the negative and positive. It separates that power from the data, so the power goes to powering the phone, the data goes to providing that data network connection, all over just one single wire here. Power over Ethernet. Really good thing if your devices need it, but the switches are more expensive. As we're looking at our switches and what switches to buy, there's a couple types of switches. We know what our layer 2 is. The basic switch down here only deals with MAC addresses. And so this is on layer 2 right here. Layer 2 switch doesn't care anything about IP addresses or anything above it. We have layer 3 switches. These layer 3 switches not only can do the layer 2 switching using the MAC addresses, but they can do routing. Some of the features of your router, they can do that. They can combine this into another device. But then we throw in, and so this was a layer 2 switch. This is a layer 3 switch that does both of these. Now we can start looking at multi-layer switches. Multi-layer switches not only do the functions of layer 2 and layer 3, but they can do functions in layers 4, 5, 6, and 7. What these multi-layer switches do typically, they have what we call application-specific integrated circuits, or ASICs. And what this is specialized hardware to do what you are doing a lot of on your network. If you are doing a lot of video streaming on your network, that's what your company is all about. You're going to get some special hardware in your multi-layer switch to optimize, to switch and route that video traffic. Now, ASICs, along with dedicated software, can streamline forwarding IP packets independent of the CPU. And that's the big thing here. It's independent of the CPU. Now, the CPU in a multi-layer switch, they're concerned with doing layer 2, layer 3 switching, but then you can add in some of this ASIC hardware to handle what you're doing on your network, typically what you're doing a lot of on your network. Then that would be handled in the processor here, and then the CPU would be handled here. Now, what can we do? Well, we can do like context-based access control. Access control lists work down here on layer 3. Standard looks at source IP address. Extended looks at source destination IP addresses, looks at your protocols, TCP, UDP, what layer 4 ports you're using. You can filter on that. Any more than that, you can't do that. But with a context-based access control, you can actually look at what are the users sending across the network? What applications are they using? What websites are they browsing? What protocols are they running? When you're looking at your switches and you're getting ready to pick them out, there's a lot of things to look at. I wish I could give you a simple answer that said, use this switch or use this switch and that's it. But what we have to do is we have to look at a whole bunch of different factors. You have to look at the cost. How much are you going to spend on your network? That's usually a difficult question to ask, but you need to know that. Are we looking at buying some cheap switches? If your budget's $300, you can't go into enterprise level stuff. You're going to have to go off of a website, buy a switch that's unmanaged where you can't create VLANs or quality of service or anything like that. And you're going to spend $300 for a gig switch there. Now, if you have a bigger budget, if you got $10,000, you can go and buy an enterprise level switch that you can have VLANs on. You can put quality of service on there. You can have power over Ethernet. So cost is usually one of the big things you need to look at right away. Then you need to look at port density. How many ports do I need? What do we think our future is going to look like? With port density, you have to say, okay, I'm going to have 20 devices connected into here. Now, am I expecting this area to grow? Well, we've seen that devices in this area, we've been adding 4 a month. Well, if we had 20 devices now on a 24 port switch, we're going to be full in a couple of months. So maybe we need to look at, instead of spending $1,500 for a switch, let's spend $2,000 switch for a switch and give us another additional port, or another 24 ports. That $1,500 will get you about a good 24 port switch. Add in another $500, that will add you in, double your ports, add in another 24 ports for another $500. That will allow you to grow for a couple years without having any issues with your switch and the available ports. What type of power do you need? And what we're looking at here is power over Ethernet. Do your devices need power over Ethernet? Are you going to have phones and access points and cameras all connected in there that need that power over Ethernet? Or is it just a laptop with a wired connection, desktop PCs? And when you power a device, you can plug in a wall adapter. So you need to think about what the power requirements of your devices are. What's your reliability? How important is that network to you? If your network goes down, well, you run to the store and buy another 24 port switch, and maybe the store is 2 hours away, so it's going to be a 4-hour round trip and a couple hours to install. If your company can live without that network for 6 hours, you may not have to buy that $2,000 switch. You may get away with a $300 switch. But if your network goes down and your company is losing $10,000 an hour because of lost productivity, salespeople aren't being able to sell, your assembly line is down, you can't pass quality control, then you may have to look at saying, okay, we need to have an enterprise level switch. We even may need to have a backup on hand. So not only do we need to buy that $2,000 switch, we need to buy a second one, put it on the shelf just in case it goes down. Because if that switch goes down and you have one on the shelf, over lunchtime you could have that new switch installed, hopefully no lost productivity or very little lost productivity. You need to also look at port speed. What are my end users doing? Are they doing email, browsing web traffic? Are they doing all their ordering online through websites? Or is video conferencing a huge portion of their day? If all they're doing is web and email, you may get away with fast Ethernet, 10100 port switches. If they're doing a lot of video conferencing, you may need to go into gig switches. If this switch is going to be used in your data center to connect up to your servers, you may even have to go to a 10 gig switch. You'll also have to look at the ability of your switch to store frames, because this is important in a network where there may be congested ports to servers or other areas of your network. That would be your frame buffers. And then we have to consider scalability. Now, the number of users on a network typically grows over time. The switch should provide for that opportunity of growth. It was my pleasure to provide you with this wonderful episode on switch hardware. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all of these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation for the CCNA. Thank you so much for watching this episode of my series on enterprise networking, security, and automation for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.